Now done? Okay guys, so sorry, maybe the sound was not coming up. Once again, this is Rakesh Talreja welcoming you to the session. Yeah guys, so quickly confirm now the audio should be there. Just quickly confirm it should be fine now. Right. All right. Yes, it's fine now. So great. Sorry for the inconvenience. So yeah, as I was just telling you that we started with some concepts of calculus from engineering mathematics. I first began by telling how important mathematics could be and what could be the best way of scoring 13 out of 13. And now we have started some concept classes. We started with the continuity differentiability concept. We also went through the question practice. Today is relatively a simpler topic, but I'm telling you, it's a frequent topic. I mean, there's like a bonus. एक बोलते ना लड्डू देता है आपको IIT Bombay. This is just like that. Not only IIT Bombay, any IIT. Next year IIT Kanpur is going to conduct the exam. So this is important just for the frequency point of view. I mean, you know, expectation of questions is there from this topic. Rest, this is very simple. Okay, but yeah, there are certain good questions that can be framed. That also we are going to look into this particular session. So let's get started, guys, and quickly do share the session to all your friends, juniors, all those who are preparing for the GATE 23, so that most of them can get benefited by this session. Yes. Okay, cool. Yeah, so guys, let's get started with the session and then just a second, guys. What is the issue? Yeah. Okay, so in case somebody new to my session, this is a brief intro about me. Good evening all. Keep joining the class. This is your mentor and educator Rakesh. I have secured all India rank 9th in the GATE examination, completed my masters from Indian Institute of Science, Bangalore, and it's been more than 11 years training in this industry. Yes guys, so very important update you know, for the future aspirants of GATE or ESE. Yes, if you want to prepare with the GATE preparation program of BYJU'S Exam Prep, and if you need financial assistance, yes, the BYJU'S Exam Prep here gives you an opportunity to prove yourself and hence get up to 90% scholarships. Up to 90% scholarships, right? So this is a scholarship test to be conducted on this Sunday, that is day after tomorrow, 3rd April at 11 AM. And it's going to be a 1-hour duration examination, right? And using the BYJU'S Exam Prep platform, as you might have already come to know, you might have seen the interaction with these toppers. Yes, the BYJU'S Exam Prep students and users have outshined in the GATE 22 examination, and we have all India rank 1, 2, 3 and whatnot, multiple ranks under 50 and under 100. Yes, so hope that you know, you also join this Hall of Fame, and let's get started with the question. So guys, there are, you know, some common indeterminate forms. Okay, that you must always remember. Now, what exactly I mean by indeterminate form means, see, there is a difference between indeterminate and undefined. Some students get the confusion that indeterminate means undefined, right? So if I say 0 by 0, is it undefined? Is it infinity? Yeah, to apply for scholarship test, you just have to log into the BYJU'S Exam Prep app, and you will just automatically see the, you know, scholarship test details on the front itself, right? Okay. So 0 by 0, guys, maybe a finite quantity also, maybe 0 or maybe infinity also. So that's what it is. Directly not possible to say what can be 0 by 0. We have to apply some more mathematics and come up with the final answer. So directly by looking into this, I can't say what's the answer, whether it is 0 or infinity or finite, right? We call it as an indeterminate form. Similarly, infinity by infinity is indeterminate form. 0 into infinity. Infinity minus, we'll take up questions on all of these areas. Actually, we'll take up the questions on all of the areas, don't worry, right? But infinity minus infinity, students sometimes thinks ki are same number being subtracted, so answer should be 0. But infinity is something which we cannot measure. Okay, maybe my definition of infinity, maybe your definition of infinity can be different. Something, you know, the largest I can think in this world, Right, so that is why infinity minus infinity does not make it 0. It may be 0, it may not be 0. So it is an indeterminate form we have to solve, and it is a form which has to be converted to 0 by 0 or infinity by infinity, because eventually when you are going to solve the problem will boil down to the L'Hospital's rule. Okay, the problem will boil down to the L'Hospital rule, and the L'Hospital rule is applicable only for these two forms, that is the 0 by 0 or infinity by infinity, right? And whenever you have 0 by 0 or infinity by infinity form, then limit x tending to a fx upon gx, if it is 0 by 0 or infinity by infinity, can be solved as limit x tending to infinity f dash upon g dash. F dash x is divided by the g dash x, right? The next indeterminate form that I would like to discuss, and we will see questions coming up on everything, is 0 power 0, 1 power infinity. Now sir, why 1 power infinity? Why 1 power infinity? So see guys, if it is actually 1 power infinity, then yeah, truly the answer will be 1. But what is the type of question you are going to get? Okay, what is the type of question you are going to get? Suppose if I tell you limit of देखो यहाँ पे रखते हैं 1 plus 1 by x, limit x tending to infinity, sorry, have a look at this, raised to the power x, limit x tending to infinity 1 plus 1 by x raised to the power x. How to solve this? What is the formulation? That also we'll see, but first try to understand the concept. So this becomes how much? If x is tending to infinity, 1 upon x will be tending to the 0, na? 1 upon x will be tending to the 0, and already in the first class of continuity, when I basically started by the definition of limit, okay, the Monday's class, I told you with limit we write down tending to infinity and tending to 0. We do not say it is equal to 0. So 1 upon x is very, very close to 0, but it is not exactly 0. It is not exactly 0. See, okay, because if it is 1 power infinity, if it is exact 1 power infinity, that will be 1 na. 1 ko kitni baar multiply kar lo, that is going to be 1 only na. How the basic maths can change? Some students are confused in this. 1 into 1 into 1 into 1 into 1, I do it 1000 times, I do it 10,000 times, it remains 1. But since it is the concept of limit x tending to infinity, the 1 upon x is tending to 0. So this is either approximately 1.00000 something, okay, something raised to the power infinity, or it could be, I don't know whether 1 by x tending to 0, so whether 1 by x is very, very close to 0, but maybe little greater than 0, little less than 0, because we know limits will have two criteria, right hand limit and the left hand limit, or it may be something of the form 0.99999999999, which is approximately 1 but not equal to 1 ना. So देखो क्या होगा. Okay, so what is the answer for this? That is what we need to decide. Okay, so now there is a number which is slightly greater than 1. Have a look at this, which is slightly greater than 1, and you multiply this n number of times, infinite number of times. Okay, infinite means why x number of time where x is tending to infinity. What is the answer? So this needs to be figured out. This is indeterminate right now. Okay, so indeterminate, I'm telling you, indeterminate means which is not in. I don't say it may be infinity, it may not be infinity. It is not determined directly. We have to work out little bit. थोड़ा मेहनत करेंगे तो answer आएगा, right? And then similarly 0.9999999 multiplied infinite number of times. What could be the answer? That's what we need to look into. Okay, that's what we need to look into. So we're going to see any one of these cases coming up, right, guys? Okay. Right, guys, so that is what is the concept of 1 raised to the power infinity. Otherwise, if it is, again I repeat, if it is exact 1 power infinity, then it is going to be 1 only. Okay, then there is no doubt in that. Infinity power 0. Right, now since we don't know what is the value of infinity, then there itself there is a problem. Ki, anything power 0 is 1, but what is infinity power 0? That is little bit dicey. So these are known as the common indeterminate form, right? Out of these common indeterminate form, whenever you have 0 by 0 or infinity by infinity, you can apply the L'Hospital rule, right? All other forms can be converted to 0 by 0 or infinity by infinity. And then there are some limits of special interest. I don't say you have to remember them, but yeah, these are the limits of most common interest. If you remember by default, if you remember it from the school time itself, then it is good. Otherwise, I don't say that you have to mug up the formula. You can find it out easily. Now, this is one of the most common limit x tending to 0 sin x by x. Sir, why? Okay. y. So when I talk about limit x tending to 0, sin x upon x, so देखो ना, put the value of 0, so it is known as the case of sin 0 divided by the 0. So what is sin 0? 0 divide by the 0. So sin 0 by 0, it is 0 by 0, right? Now 0 by 0 is an indeterminate form, but whenever 0 by 0 is there, I can apply the L'Hospital, right? So whenever I apply the L'Hospital, what I am going to get? I will get limit of x tending to 0, differentiation of numerator and denominator. Sin x ka differentiation is known as the cos x divided by x differentiation is 1, and the answer is known as the cos 0, and the cos 0 is equal to the 1, right? That's why limit x tending to 0, sin x by x is 1. So nobody asks you to remember this, and there are some more limits of common interest that you must keep on remembering. This can be derived using this only if you take x in the denominator as 1 by x, right? This is the same thing as I told you, x tending to 0. यहाँ पे हमने x tending to infinity लिया, this is x tending to 0. तो 1 raised to the power 1 by 0, 1 raised to the power infinity, the form I was discussing. 1 raised to the power infinity is e. Sir, why? We will prove it, don't worry. We shall prove it, okay? We shall prove it. Don't take attention on this one. Limit x tending to 0, e power x minus 1 upon x. Apply L'Hospital, you are going to get it as 1. So these are limits of common interest. Okay, if you remember, good, but I don't insist you to remember. I don't ask you to mug up any of these things, right? Existence of limit. Now this concept I've already covered in the first class. I will just write down. Okay, इसका जो concept है ना, इसका जो detailed concept है, that was covered within the first class. Okay, you can watch the class of Monday. What was the day on Monday? I think 28th March class. If you watch, you will get the concept, existence of limit concept. A limit, I will write down just as a revision. Limit x tending to a fx exists if what? If limit x tending to a minus fx, left hand limit, is equal to limit x tending to a plus fx, right hand limit, is equal to the value of the function at the point a, should be equal to fa. Should be equal to what? Should be equal to the fa. That is what is the condition for the existence of the limit. Why it is so? The detailed concept you can get it on the Monday's class, the first class of this series, that is on 28th of March. That is available on the same channel. So let's get moving ahead. Okay, so let's directly come to some of the basic questions. Yes, let's directly come to some of the basic questions. Come on. What is the value of limit x tending to 0, 1 minus cos of x square divided by 2x power 4? Okay. Come on guys, everybody. What is the limit of x tending to 0, 1 minus cos of x square upon 2x power 4? So it's a simple case then, right? What should be the answer? It is given by 1 minus cos of 0 upon 2 into 0. Cos 0 is 1. Right, and 1 minus 1 is 0. So this is the 0 by 0 form, and whenever you have the 0 by 0 form, you will apply the L'Hospital rule. According to L'Hospital rule, I shall differentiate both numerator and denominator individually. Limit of x tending to 0, 1 ka differentiation 0. What is the differentiation of cos? Minus sin theta. Cos theta differentiation is minus sin theta, minus sin of x square. But by the chain rule, differentiation of x square is 2x whole divided by 2. The differentiation of x power 4 is the 4x cube. X power 4 का differentiation है 4x cube. ठीक है? Okay, so 1x and x cancelled. So now this is given by minus also cancelled, 2 cancelled. This is 1 by 4 constant outside. Limit of x tending to 0. What is left, sir? Sin of x square divided by x square. Dekho, one of the x is also cancelled. Now can I say the answer directly, guys? Limit of, if x is tending to 0, x square also tending to 0, na? If x is tending to 0, automatically means the x square also tending to 0. Right, so this becomes how much? This can be written as x square tending to 0, and then hence it is of the form sin theta by theta, theta tending to 0, and that limit is 1. So the answer is 1 by 4. So the correct answer for the question should be equal to the 1 by 4, option number C. Simple one, simple one, simple but yet expected. So these are just like today's class is just like a, you know, feel good class for you, I can say. You can sometimes, if the questions come and they keep on coming, you can score easily. Next question. What is the value? So see, it's a gate 1 mark question directly. What is the value of limit x tending to 0, x cube minus sin x upon x? Limit of x tending to 0, x cube minus sin x is divided by the x. X cube minus sin x is divided by the value of x. Tell me. Limit of x tending to 0, x cube minus sin x divided by the x. Come on guys, tell me the answer. Okay, a very simple case again. चलो इसको discuss कर लेते हैं. Okay, so once again if I put 0, so this is 0, then sin 0 is 0 upon 0, eventually 0 by 0 form. Whenever you see the 0 by 0 form, you have to start applying the L'Hospital rule. Okay, and if I apply the L'Hospital, right, if I apply, or you know, here L'Hospital also not required. Dekho, here L'Hospital also not required. What you can directly do here is, this is the limit x tending to 0, divide by x directly. So that is known as x square. Divide by the x, so x cube upon x is x square, minus sin x by x, right? Minus sin x by x. Now what should be the answer? X tending to 0, so x square directly tending to 0. If x is tending to 0, sin x upon x is tending to 1, already we discussed. So this is 1, so the answer is directly minus 1. No need for the L'Hospital here. There is no need for the L'Hospital here, right? Our correct answer is option number D. Boliye, finish. Simple, sir. This one is the simple. Okay, chalo. That's what. Be ready for some bonus questions also. So GATE is not always about tough questions. It is a combination of some easy concepts and some good concepts. Okay, so log of 1 plus 4x is divided by e power 3x minus 1. Is divided by the e power 3x minus 1. Check kar lete hain. So x tending to 0. So this becomes log to the base e hai na? Log to the base e, that means it is a natural log. So let me write it as ln 1 plus 4x, x tending to 0. So ln 1 divided by e power 0 minus 1. Okay, log 1 is 0 and 1 minus 1 is also 0. So this is the 0 by 0 form. This is the 0 by 0 form. Yes, point ohms. If it is up to infinite times addition, yeah, it will be infinity. And that's very sure. Okay, this is 0 by 0 form. So what I can apply here is the L'Hospital rule. If I apply the L'Hospital rule, this becomes the limit of x tending to 0, log ka differentiation 1 upon 1 plus 4x. If it was log x, the differentiation is 1 upon 1 plus 4x. But by the chain rule, when you differentiate 1 plus 4x, the answer is equal to the 4. Whole divided by the differentiation of denominator, e power 3x ka differentiation, 3 e power 3x. 3 e power 3x, right? Now if you put the x tending to 0, so that is 4 divided by 1, whole divided by 3 e power 0, that is 1. So final answer that is coming is 4 divided by the 3. 4 is divided by the 3 and hence your answer is option number C. Yeah, that's what I see in the comment box also. Simple one, correct answer is option number C. Correct answer is option number C. Next. E power x minus 1 plus x square by 2 whole divided by x cube. Now there can be the two ways of solving this question. There can be the two ways of solving this question. One is the regular method. First put x tending to 0, so e power 0 minus 1 plus 0 plus 0 divided by 0 cube. E power 0 is 1, so 1 minus 1 is known as the 0 divided by 0. The answer is 0 by 0. The answer is 0 by 0. Answer is 0 by 0. Correct. Now, if it is 0 by 0, I will go for the L'Hospital rule. And if I go by the L'Hospital rule, I differentiate this e power x minus 1 ka differentiation 0. Differentiation of x is 1. X square by 2 differentiation will be x divided by 3x square. But this is once again, dekho, e power 0 minus 1 upon 3 into 0. E power 0, 1. 1 minus 1, 0. So this is again 0 by 0 form. This is again known as the 0 by 0 form. ठीक है, अच्छा जी. Okay, so once again L'Hospital means this is going to become limit x tending to 0 e power x minus 1 plus x ka differentiation 1 upon 3 2s are 6x, and this is still e power 0 minus 1 upon 6 into 0, 1 minus 1, this is still 0 by 0. If it is still 0 by 0, so one more time L'Hospital rule. Okay, so यहीं पे करते हैं. One more time L'Hospital rule if I apply, what is the answer I am going to get? Differentiation of This is limit x tending to 0. Differentiation of e power x is e power x divided by differentiation of 6x is equal to 6, and answer is, यहाँ लिख देते हैं, answer is 1 by 6. The correct answer is 1 by 6. Correct, yeah, that's what is there in the comment box also. The answer is 1 by 6. The answer is 1 by 6. Right. Can I do it some other way? Right. Or what is the alternative that you can do? What is the alternative you can do? Alternative is you can solve the question even by applying the Taylor series. Okay, the expansions, the Taylor's expansions or the Maclaurin's expansions of the exponential function, right? What is the e power x? E power x is given by 1 plus x square by factorial 2 plus x cube divided by the factorial 3 plus x ki power 4 is divided by the factorial 4 plus up to infinite terms, right? So when you have the limit of x tending to 0, e power x minus 1 plus x square by 2 is divided by x cube, that is going to become limit of x tending to 0, 1 plus x square by 2, 2 factorial is 2, so this term is completely cancelled. Your answer starts from x cube by 3 factorial and divide by x cube also. When you divide by the x cube, you have 1 by 3 factorial plus x power 4 upon x cube, x by 4 factorial. Next आ जाएगा x square by 5 factorial, etc. But ultimately x is tending to 0 na? Ultimately the x is tending to 0, so all of these terms will be 0 and the answer is simply 1 upon 3 factorial. What is the value of 3 factorial, sir? What is the value of 3 factorial? That is equal to the 6, right? So the answer is 1 by 6. The answer is 1 by 6. So that is another way of taking this, either by the series or either by the regular L'Hospital rule, right? Chalo. Next one, limit x tending to 0, x minus sin x upon x plus cos x. And let me tell you that, one second. Yeah, if you put x tending to infinity, infinity minus sin infinity upon infinity plus cos infinity. Now sin infinity, I don't know what is the value of infinity, so I can't say what is sin infinite. But yeah, it is going to be a finite number because sin theta and cos theta are both bounded between -1 to +1. They cannot be infinity, right? So infinite minus a small number will be infinite. Infinite plus a small number, it is a infinite. It is infinity by infinity form. So if I apply the L'Hospital rule, I will write limit x tending to 0, differentiation of x1, differentiation of sin x is cos x, divided by x ka differentiation 1 and cos x ka differentiation minus sin x, and this is known as 1 minus, what is cos infinity? Do you know what is cos infinity? Sir, I don't know. 1 minus sin infinity. No, I don't know what is that value. So there are 2 question marks, right? That I don't know, Ananya. That you have to, what are the conditions, that you can check on the app only, right? That is what it is. Are you getting it? So I'll be stuck here. We are just stuck here. We cannot conclude. L'Hospital is applicable, but we are stuck. We can't go forward. So what is the way of solving this particular question? Guys? Can you take it up? What is the way of solving this particular question? Can you just take it up and see what's the answer? Chalo, tell me. Okay. Yes. No, answer is not going to be infinity. So what I can do is, there is a method that can save you. Limit x tending to 0, x minus sin, x tending to infinity, x minus sin x upon x plus cos x. What you can only do is divide by the x throughout. Divide by the x in the numerator and denominator. Divide by the x throughout. So this becomes the limit of x tending to infinity. Divide by x kiya to 1 minus sin x by x upon 1 plus cos x by x. Now we know that sine infinity is finite, okay, but x is tending to infinity. So what is 1 upon infinity? Right, this is 1 minus some finite value divided by infinity, and 1 plus cos infinity is also some finite value. I don't know what is the value, but there is some finite value. Now suppose f1 and f2 divide by infinity, but finite upon infinite is 0. So 1 minus 0 upon 1 plus 0, and hence the answer is 1. Hence the correct answer to the question is equal to the 1. The correct answer to the question is simply equal to the 1. Is simply what? Is simply equal to the 1. Correct. All cool. बहुत ही बढ़िया. चलो, moving ahead to the next question. Limit of x tending to infinity, 1 plus 1 by x raised to the power 2x. Limit of x tending to infinity. अच्छा. As always, you will get the PDF of the class, okay, which will be password protected. Only the students which are watching the session, they'll get the password, and the password is going to be just a very simple password. I'm floating to the limits, dependent on the topic. It's limits. That is going to be the password for today's PDF. Yeah, now that is of the form. Now this one is of the form 1 raised to the power. Okay, 1 plus 1 upon infinity, that is 0, raised to the power 2 into infinity. Now, that is basically 1 power infinity form. Correct, guys? What is this question? This is of the 1 power infinity form. And 1 power infinity form, now there are the two ways of taking this question. Okay. There are the two ways of taking this question. Number one, right? Number one. Either the formulas that I told you, limits of special interest. I told you, limits of special interest. This is limit x tending to infinity, 1 plus 1 by x raised to the power 2x. Na? So raised to the power 2x can be written as raised to the power x raised to the power 2. Now what is limit? If you remember the limit of special interest, you can write this as 1 plus 1 by x ki power x for x tending to infinity was equal to 2. So the answer is e square. Now that is formula based, right? So that is formula based, okay, right? Two same number is divided. Which two same number? Satya Srinivas, right? So the answer is e square. There is no doubt in that. The answer is e square eventually. That is going to be right. But what is the actual logic of 1 power infinity? How to solve the question, sir, if I don't remember the formula, if it is any other form involving 1 power infinity? So because it is the power case, na, simple way is taking up the log. Okay, so what is the method number 2? यहाँ पे देखेंगे. What is the method number 2? It is limit x tending to infinity, 1 plus 1 by x, 1 plus 1 by x raised to the power 2x, and let this be equal to y. Okay, let this be equal to some number y. Okay, let this be equal to some number y. So take the log of this. Take the log of this, and when you take the log, it becomes limit log of y, limit x tending to infinity, power will come outside, that will become 2x log of 1 plus 1 by x. 2x log of 1 plus 1 by x. ठीक है जी? Now send this x in the denominator. Okay, send this x in the denominator. 2 को तो outside रख लो. 2 limit of x tending to infinity log of 1 plus 1 by x, and when you send x to the denominator, it will be written as 1 by x, na, reciprocal form में. Okay, now this is clearly of the form x tending to infinity. So this is of the form 2 log of x tending to infinity, 1 by x tending to 0. So bacha only 1 divided by 1 by infinity. 1 by infinity is 0. Log 1 is also 0. So this is 0 by 0 form. And now because you have the 0 by 0 form, you can apply the L'Hospital rule. Chaliye sir, let us go and apply the L'Hospital rule now. Okay, let us go and apply the L'Hospital. So if I apply the L'Hospital to this, that becomes twice limit of x tending to 0 log का differentiation 1 upon 1 plus 1 by x. Log x differentiation is 1 by x. So 1 upon 1 plus 1 by x. But by the chain rule, if I differentiate 1 plus 1 by x, it is minus 1 by x square. But then in the denominator, when you differentiate 1 by x, that is also minus 1 by x square. So this is cancelled. So the answer is twice 1 upon 1 plus 1 by x. And x is tending to infinity. 1 upon infinity is 0. So the correct answer is 2 only. The correct answer is what? The correct answer is 2. Right, that is another way. So, you know, whenever it is the power based limit question or 1 power infinity and infinity power 0 cases which are indeterminate form, you can use this method of taking the log, or else if you remember the limit of special interest that I have shown you in the beginning, it could be a formula based approach. Answer is eventually same. Acha, okay, sorry, this is the 2, but this is what? This is the answer for log y. Just let me complete this. Okay, this is the answer for log y. That means log y is equal to 2. So what should be the value of y? Value of y is e power 2. Just one last step. Okay, the value of y is equal to the e power 2. Eventually the answer is the same. No problem here, right? Okay, now what is this? Limit x tending to infinity. The infinity plus infinity minus 1 of course will be infinity. Under root of infinity is infinity. So this is of the form infinity minus what? Minus again x, which is infinity. So this is infinity minus infinity form. Whether it is equal to 0. So I told you in the beginning also, some students believe that it may be 0, but why it may not be 0, I explained the logic also. So what it is actually, wo hum samjhenge. Infinity by infinity is what form? It is one of the indeterminate form. It is one of the indeterminate form that we discussed in the beginning. It is what? It is one of the indeterminate form. How to solve this question? How to solve this question? So now what you can do to solve this question is, take it here. We have the limit of x tending to infinity under root of x square plus x minus 1, right? Let me write down the complete expression. Minus x. Okay. Minus x. Okay. Yeah, rationalization is also one of the method. Let's try to make it even more little simpler. Okay, let's try to make it even more little simpler. Put x is equal to 1 upon t. Put the x is equal to 1 upon t. So this is going to become limit, dekhenge abhi hum, under root of x square, that is under root of 1 by t square, plus x plus 1 by t minus 1 minus of x. Minus of x, that is minus of 1 by t. Now because the expression is in t, the limit should be for t, and if x is tending to infinity, so t should be tending to 0, reciprocal hai. So now I convert this into limit t tending to 0. Now can you solve it up? Now it is easy. Now it is easy. Like when you take up the common in this denominator, it will be t square, under root of t square is t. So whole denominator is equal to the t. Yahan pe aa gaya, whole denominator is t, this is 1 multiplied by, so this is t, then minus t square minus 1 for limit of t tending to 0. And now because t tending to 0, so this part is 0, under root of 1 is 1, 1 minus 1 0 divided by 0. Now as I told you in the beginning also, na, infinity minus infinity is an indeterminate form but convertible to 0 by 0 or infinity by infinity, and I have converted this to 0 by 0. If I have converted this to the 0 by 0, na, I hope you can solve it up. Come on quickly. Yeah, because I have converted this to the 0 by 0, then you can solve it up easily, right? I don't see any much difficulty there, right? Yes, guys. Come on. Tell me. Chalo, let's do it then. Yes. Correct. 1 by 2. C will be the correct answer. So 0 by 0 form hai. So time to apply L'Hospital. And if I apply the L'Hospital, I'm going to get limit of t tending to 0. Differentiation of root x term number 1 is 1 by 2 root x. Okay. Into by chain rule differentiation 1 minus 2t, differentiation of 1 is 0, divided by the differentiation of only t in the denominator, which is 1. Acha ji. Now, if I directly put the value t tending to 0, this is 1 by 2 under root of 1 plus 0 and 1 minus 0. 1 minus 0 is 1, under root of 1 by under root 1 is 1. So answer is left 1 by 2. The answer that is left only is 1 by 2. So the final answer is option number C. Okay, the method number 2 could be, just try it on your method number 2 can be rationalize this. Rationalize means this is a minus b form, na? So multiply and divide by a plus b. Multiply and divide by the a plus b. Rationalize method. Okay, but you can try it yourself if you want to try. Right. Limit of x tending to 1, a GATE 21 question I've taken here. Limit of x tending to 1, 1 upon log x minus 1 upon x minus 1. Limit of x tending to 1. So what is this form? Basically, this is of the form 1 upon log 1 minus 1 upon 1 minus 1. Now log 1 is 0. So 1 upon 0 minus 1 upon 0. 1 upon 0 is infinity. So once again we have infinity minus infinity indeterminate form here. Once again we have infinity minus infinity. But as I told you, infinity minus infinity is indeterminate. We can't say the value directly. But it is convertible to 0 by 0 and infinity by little bit of the effort. So what to do? Let's try to write down this expression as a whole. Na? So this is going to be limit of x is tending to 1, x minus 1 minus log x divided by x minus 1 log x. X minus 1 minus log x, just taken on the common scale, divided by x minus 1 log x. Now when x is tending to 1, okay, this is 1 minus 1, right? This is 1 minus 1, which is 0, minus log 1 is 0, divided by 0. So now it is the 0 by 0 form. So apply the L'Hospital. Yeah, this is 21 question. Apply the L'Hospital. When you apply the L'Hospital, you get the limit of x tending to 1. Differentiation of x minus 1 is just 1. Log x ka differentiation 1 by x. Okay. In the denominator, right, what to do? In the denominator, yes. So again differentiated denominator, but product rule has to be applied. X minus 1 constant, differentiation of 1 by x is differentiation of log x is 1 by x, plus log x constant, differentiation of x minus 1 is just equal to 1. Now if you try x tending to 1, so what you are again going to see, 1 upon 1 is 0, 1 upon 1 is 1, so 1 minus 1 is still 0, right? X tending to 1, 1 minus 1, 0, log 1, 0, so this is still 0 by 0 form. So can I try L'Hospital one more time? This is the still 0 by 0 form. So can I apply the L'Hospital one more time? Sir, why not? Try kar lete hain. So if I again apply the L'Hospital, I get limit of x tending to 1, 1 minus 1 ka differentiation 0, 1 upon x ka differentiation minus 1 by x square. So minus minus getting plus. Now just do this calculation here. X upon x cancelled as 1, 1 ka differentiation 0. Then you have what? Then you have minus 1 by x, whose differentiation is again 1 by x square, and log x ka differentiation is 1 by x. Log x differentiation is 1 by x. Now put x tending to 1. So 1 upon 1 plus 1. Answer to the question 1 by 2. Boliye ho gaya solve? Yes, answer to the question is 1 by 2. The answer to the question is 1 by 2. All right, everybody. The answer to the question is 1 by 2. So we are trying to take, although it's a simple topic, but trying to cover the different variety of question. Now come to this. This is the important question. Find the values of the constants a and b such that the limit x tending to infinity, x square plus 1 upon x minus 1 minus ax minus b is equal to the half. Okay. The limit x tending to infinity, x square plus 1 upon x plus 1 minus ax minus b is half. So now this is a good question where the answer of the limit is given, but there are some unknown constants a and b to be figured out. There are some unknown constants a and b that you need to figure out. ठीक है जी? Okay, chalo. So let's start solving this. Okay, let us start solving this. Let us start applying some mathematics on this. So this is actually the form limit of x tending to infinity, x square plus 1 minus, multiply there completely, minus ax into x, ax square minus ax into 1 minus bx minus b whole divided by the x plus 1. That is what is given to you. That is what is given to you. That is 1 by 2. Acha ji. Now this is clearly of what form? इसको आंसर को बाद में लिखेंगे. This is clearly what form? Numerator has x, denominator has x, and x is tending to infinity. So this is infinity by infinity form. This is infinity by infinity form. So as soon as you get infinity by infinity, quickly start applying L'Hospital. So if I apply the L'Hospital, I am writing this as limit of x tending to infinity. X square ka differentiation 2x minus 2ax minus a minus b whole divided by 1. Whole divided by 1. Okay. अच्छा जी. Okay. Now, देखो ध्यान देना. This is of what form? Let me write here. We have limit of x tending to infinity. Okay. 2x को common ले लें. If I want to take the 2x common, then I am left with 1 minus a minus b whole divided by 1. Right. Now, if x is tending to infinity, guys, if x is tending to the infinity, na, so if x is tending to infinity, this becomes infinity by 1, that is infinity. That is infinity. But question has already given me the answer. The answer should be half. Okay. The answer should be half. Right. Okay. So, we need half, yeah, whatever it is, we need finite answer. But infinity upon 1 though, sir, will be infinity only. Now, how I can make the finite answer? What is the possibility to make the finite answer? The possibility is infinity kiski wajah se hua? Why this infinity comes? Because there is the x here. Okay, there is the x, but there is a coefficient of the x which is 1 minus a. If I remove this 1 minus a, then my problem will be solved. If I remove means take it as 0. So if I take the 1 minus a equal to 0, then my problem is solved and I can take the a is equal to the 1. If I take the a is equal to 1, then my problem is going to be solved. Yeah. So let's take the value of a is equal to the 1. So now then it becomes the limit of the form. Okay, then we have limit of x tending to infinity. 1 minus a to 0 ho gaya. Minus a minus b upon 1 is equal to the half. Okay, now already I have decided what should be the value of a is 1. So minus 1 minus b is equal to the half. From here I also get the value of b. b kitna ho gaya? Minus 1 minus half. Minus 3 by 2. A is 1, b is minus 3 by 2. That's my answer. A is equal to 1, b is equal to minus 3 by 2. That's a good question. Okay. A is equal to 1, b is equal to minus 3 by 2. So the limit is given, you have to find some constants. If your concepts are clear, you are able to solve it up. Related to this, let me give ABD, please specify the doubt, which step you have the doubt, then more better. Okay. Full repeat karenge, then full repetition means you can watch the video again also. Okay, related to this, let me give you one homework actually. Then we will come back to this question. I'll give you two homework. This is one homework. This is a regular question. You can solve it up, guys. This is a regular question, nothing much here. This is a homework for you. And this is related to the earlier question. The value of limit is given to you. Not exactly given, but the limit is b, where b is a finite value. So the answer should come up as a finite number. What should be the value of a and b? What should be the value of a and b? Simple hai. If you have understood that question, what we have done, this can also be solved. This is the homework. These are two homeworks for today, right? Yeah, this is one simple limit question. Let's wrap up this one. Okay. So now, what is the limit x tending to 5 by 4, x minus floor x, where x is a step function? Where x is a step function. Very, very simple question. Limit of x tending to 5 by 4, x minus step x. I already explained you the step function in the first class. Monday's class you can watch. So this is simply 5 by 4 minus floor of 5 by 4, which is 1.25. So that is equal to 1. 5 by 4 minus 1 is 0.25. That is a simple answer. इसमें कुछ सोचने लायक नहीं है. The answer is 1/4. The answer is known as the 1/4, option number A. But suppose if I frame another question, the question is limit of x tending to suppose 6. Okay, not like this. Let me take it like this. Yeah, okay, that is fine. Limit of x tending to 6, floor x. Okay, limit of x tending to 6, floor x. Okay, what should be the answer for this? Correct, ABD. What should be the answer for this? Let me say the option number A is 6. Let me say that the option number B is 7. Let me say the option number C is 5. Let me say the option number D is... Tell me the answer. Oh, so answer is coming out to be 6. Answer is coming out to be 6. That's what you are telling. If you remember the first class, मैं वो test करने के लिए आपको बोला, right? Try to recall, guys. Try to recall, everybody. Please just try to recall that the step function is discontinuous at integral values of x. You remember the graph? You remember the graph? ये तो मैं suddenly question ले लिया, guys. We have discussed this in the first class, so randomly I framed this question, and guys, with a big heart, Abhinav Negi sir. Okay, the civil champions will be excited to see, and not only civil champions, all the Byjus stars will be excited to see. Welcome Abhinav sir to the session. Welcome Abhinav sir to the session. Yes guys, have a warm welcome to Abhinav Negi sir with, you know, bigger hearts, bigger emojis, fire emojis, जो मतलब एकदम fantastic तरीके से यार कुछ धमाल कर दो जैसा आपका मन करे. So remember guys, हमने discuss किया था in the first class that the step function is discontinuous at all integral values. Remember the graph? चलो just a second, sorry. Remember the graph? You know, हमने graph भी discuss किया था. Hey, this is 1, 2, 3, 4, and etc. It's discontinuous. Left hand limit. What was the condition of discontinuity? The left hand limit at the integral point does not equal to the right hand limit. Graphically, we understood this question. The left hand limit does not equal to the right hand limit. We also called this as the staircase graph. Right, floor function, GIF function. What was the name for this? Either known as the floor function or a step function or GIF function or a staircase graph. It has a staircase graph. एकदम सीढ़ी जैसे 1 by 1, 1 by 1, 1 by 1. ठीक है जी. चलो ये तो मैंने randomly पूछ लिया. Let's come back to our question. Yeah, this is also, you know, with respect to limits, if I say this is a good question. Otherwise, limits के mostly the questions are very straightforward. But what about this one? What about this one? Okay, sorry, this is not a limit question. We can solve this question directly also. Let f of x plus y is fx into fy for all x and y, where f0 not equal to 0, f2 is 2, and f dash 0 is equal to 3. What is the value of f dash 5? What is the value of f dash 5? Okay, what is the value of f dash 5? So basically this is a concept of differentiation based question. ये इस slide में आ गया है, but yeah, we can discuss this. It's just a conceptual question. F of x plus y is fx into fy for all x and y, right? f0 not equal to 0, f2 is 2, f dash 0 is 3. What should be the value of f dash 5? So what is the concept here? The concept is the concept of differentiation, right? Concept here is the first principle of differentiation. The concept here is the first principle of differentiation. The derivative of a function at this point, f dash x, is given by limit of h tending to 0, f of x plus h, change in the function upon change in x, change in y divided by change in x when the change in x is considered to be small. This concept is again we have understood in the first class. Related to it, questions are now coming up. So if I want to discuss the value of f dash 5, so sir, that should be equal to the limit of h tending to 0, f of 5 plus h minus f of 5 divided by the value of h अच्छा सर, f5 तो given है मेरे को, f5 is equal to 2, but what is f of 5 plus h? So there is a function which satisfies f of x plus y is fx f5 for all values of x and y. So this is going to become the limit h tending to 0 f5 fh, right, minus f5 divided by the value of h, okay. So now what should be the answer? We know what is the value of f5. f5 का value 2 given है, तो वो यहाँ पे substitute कर देते हैं. So I have limit of h tending to 0, right, 2fh minus 2 divided by h. Now try to put h equal to 0 na. Try to put h equal to 0. So 2f0 minus 2 divided by 0. Sir, what is the value of f0? Dekho, what is the value of f0? Tell me. What is the value of f0? That is not equal to 0. That is not, nah, f0 should be equal to 0. That is not equal to 0. What is the f0 कुछ, हाँ ठीक है, f0 निकाल लेंगे ना यार, कितना समय लगेगा. f0 is not equal to 0. It will give you the simple answer. It will give you the simple answer कि अगर x और y दोनों को 0 किया, x and y are both equal to 0, तो f of 0 plus 0 is f0, that is equal to f0 का whole square. Okay, so then there are the two roots to this. f0 square is f0, so the answer is 0 or 1, but that is why they mention f0 does not equal to 0, right? So f0 does not equal to 0, so what is the value of f0 is 1. What is the value of f0 is 1, तो यहाँ पे रख देंगे 1, right? So then it is 2 minus 2 divided by 0, and it is 0 by 0 form. Now you come back to the concept of limit of L'Hospital. Okay, now if you apply the L'Hospital, you get the answer. Limit h tending to 0, twice of fh, differentiate, so twice of f dash h, 2 ka differentiation 0, differentiation of h is 1. Okay, so now it is no more a indeterminate form, it is simply equal to 2f dash h tending to 0 पे रख दिया, h equal to 0, 2f dash 0, and the value of f dash 0 is given to you, that is equal to the 3, and the answer for the question is 6. बोलिए, very good question. The answer for the question is equal to the 6. The answer for the question is equal to the 6, 6 and 6. Okay, right. Okay. Yeah, other than non-integral points, just you have to ignore the integral points. It is discontinuous if you are specially talking ABD with respect to the floor function. Okay. So this part is done, and 2 homeworks I have already given you. The PDF password I have already given you guys. So that's it. Anyways, it was supposed to be a short session, but it's already 6:55 because limits is a relatively easy and one of the scoring topics from engineering mathematics. But question keeps coming. That is why I thought discussed. There can be some good questions developed that I have given you. Two better questions we have solved, and one of them I have also solved kiye, and one more question regarding finding A and B value I have given as homework also. So guys, if you are enjoying, if you are liking the concepts, do not forget to like the session, and if you want to regularly attend these sessions, do not forget to subscribe our channel so that you don't miss. Password is already given so that you don't miss any of these classes. Once again, an important update: those who are following maths class, that is every Monday, Wednesday, Friday and Sunday at 6 p.m. That is at the fixed time of 6 p.m. And guys, signals and systems. Regarding to the signals and systems, Tuesday, Thursday, Saturday, Sunday, 8 p.m. Okay, this is for ECEE. Signal and system specifically for the ECEE or even instrumentation students. Signal and system. So the next class of signal and system is like Thursday, because today we are standing at Friday. Next class is on Thursday. We are going to talk about the idea behind convolution. First, what is the concept of convolution? This Saturday we have the convolution class. So first we'll talk about what is the concept and idea behind convolution, and then in the upcoming class we will talk about how to solve discrete time convolution sum, how to solve continuous time convolution integral. All those things we'll keep taking with the different variety of question. Right. For mathematics, the next class is now Sunday. And this Sunday we are going to learn mean value theorems. Right. So Sunday, mean value theorems. Right guys, what do we have on Sunday? We have the mean value theorems. The Lagrange's mean value theorem, the Cauchy's mean value theorem, and Raleigh's theorem. These are the most important things you need to study. Questions are coming up from the mean value theorems also. And the basics of understanding mean value theorem is continuity differentiability that we have attended in the previous 2 classes. If you have not seen, you can watch. It is available on the same channel. Many of the things are content coming up. If you are mechanical civil student, strength of materials, today only. Today is Friday, yes. So MWF, Sunday, strength of materials is going on 8 p.m. Technical class is at 8 p.m. Okay. So mechanical civil can attend the strength of material by Dheeraj Sardana sir, and also the computer science students can attend the programming and data structures by Satya sir. That is also at 8 p.m. With this, I, Rakesh Talreja, will sign off. See you tomorrow with Signal, and Saturday and then Sunday we will have both the class, maths and signals. Bye bye. Thank you. Stay safe and take very good care of yourself.